Welcome to another exciting episode. See, programming, of course, it's Killmonger, the new age. So today I want us to look at relational operators. What are relational operators? Relational operators, these are operators that relates a variable to another variable. For example, here in my program, I'm saying my variable A is equal to 21 and my variable B is equal to 20. If truly A is equal to 21, here it will print it is equal, but if not, then it's not supposed to give me A is equal to B, because of course 21 and 10, these two are not equal variables, or else A is not equal to B. If A is equal to B, here it will give me that A is equal to B, but if it's not equal to A is not equal to B, it will give me here in the else statement, it will print not equal, A is not equal to B. Then we have this one is an equal operator. When two variables that you are relating are of the same magnitude, it will give us A is equal to B. Immediately the program reaches the if statement here, it will come in this loop where it's saying printf line A is equal to B. That's if truly A is equal to B. Otherwise, it will skip this loop and say A is not equal to B. So when we look at this one, it's another relational operator. It's a less than operator. If, for example, B of course is less than A, of which 10 is less than 21, so when it comes in this loop, it will say if 21 is less than B, line 2, A is less than B. Here, as you can see, A is less than B. Otherwise, it will come to the other loop and say A is not less than B. That's if it counter checks the loop and finds out that yes, A is less than B, it will give us less than B. Otherwise, it will give us this thing here. Then when we come to this other operator, it's a greater than operator, of which line 3, when the program reaches this if statement, which is on line 27 here, it will come and say print if A is less than B. What is our A? Our A is 21 and our B is 10. If A is greater than B, because we're looking at the greater operator. If A is greater than B, it will give us A greater than B. Otherwise, if it finds that 21 is less than B, it will say, it will print what is in the else if statement, of which it will say A is not greater than B. So if we were to change these variables, A to be 5 and B to be 20, and say if A is less or equal to B, it will print it's either less than or equal to. That's if 5 is less than 20, of which yes, 5 is less than 20, so it will give us this one. Then this one is great or equal to relational operator, this one here. So like I always do, I've made a simple PDF that we can be following here. Great descriptions. So if you say this statement, it checks if the values of two operands are equal or not. If yes, then the condition becomes true. So A equal to B is not true, because we are saying 10 is not equal to 21. This one checks if the two operands are equal or not. If values are not equal, then the condition becomes true. Here, yes, 21 is not equal to true, so this is not an equal to operator. This is an equal to operator. This is a greater than operator, less than operator, greater than or equal to operator, then less than or equal to operator. So let's try and run the same program and see how it will give us. So like I was saying, So when the program begins from here, it will say our variable a, which is equal to 21, and our variable b, which is equal to 10, is a equal to b. A is not equal to b, so it will skip this the first if print if line 1 is equal to b. Otherwise it will print this other thing like I said earlier. So a is not equal to b. So when you come to line 17, sorry 19, if a is less than b, that is 21 being less than b, it will give us a is less than b. Otherwise it will give us the other thing, which is a is not less than b. So from the output here, it's saying a is not less than b. Yes, a is 21 and b is 10. So it can give us that. And when we come to this one, the greater than operator, is a greater than b? Of course yes. So it will skip this one. It will print this line. Line 3 is greater than a is greater than b, and omit this one because it doesn't satisfy the statement. So let's check the output. A is greater than b. Yes, 21 is greater than 10. Same applies to this. We are saying if a is less or equal to b, of which yes, 5 is less than 20. So it will say a is either less than or equal to b. A is either less than or equal to b. Line 5, b is greater or equal to b. That's for the greater or equal to statement. If b is greater or equal to a, of course b, which is 20 here, is greater than 5 but not equal to. So it's saying it is either greater than or equal to, but in reality we are saying 20 is greater than 5. So this is all about relational operators. I would love us to start the logical operators. In the same video we proceed. So what really happens in the logical operators, I'm sure every one of us have done digital design or digital electronics, or have done some basic mathematics of Boolean expressions. So logical operators, these are just zeros and ones. The computer only understands logic operations, which are also known as binary operations, of which we have a lot of logic operators, and one of them is the most common one, is the AND operator, OR operator. So here I want us to look at these operators, of which the first one is a logic AND. In layman's language, I can say an AND operation, it's a multiplication, but when we talk of Boolean expressions, if we say multiplication, that's the wrong way of interpreting this logic operation. So an AND, we have in those doing electrical engineering, there's what they call gates. A gate, and it only takes two or one input, and gives an output of a certain type. So there's an OR gate, AND gate, NAND gate, NOR gate, XOR gate, XNOR gate, etc. So it all starts from the logical operation of C operators that we come up with those operations. So here, the first one is an AND operator. It's called a logical AND operator. If both operands are non-zero, the condition becomes true. That's it. That's why I said, in layman's language, I can put it as a multiplication operator, because binary numbers, we only have a 0 and a 1. So here it's saying if both operands are non-zero, the condition becomes true. That's if 1 and 1. When you AND a 1 and a 1, the condition becomes true. So if we say variable A holds a 1 and variable B holds a 0, A and B, the condition is false because the operands are one is a non-zero and the other one is a 1, so it will give us a false statement. These two, the second one, the 2 bars is called the logical OR operator. In layman's language, I can say an OR operator, it's the additional operator. The OR operator is an additional operator. If any of the 2 operands is non-zero, then the condition becomes true. So if we say 1 plus 0, it will give us a 1. We are saying true because it will give us a value which is a 1, and false because it will give us a 0. The exclamation mark here, it's called the NOT operator, used to reverse the logical state of each operand. If a condition is true, then logical NOT operator will make false. So here, if you AND the variables A, which is 1, and B, which is a 0, it will give us a false statement. But if you add this one, an exclamation mark, it will give us a true because it will invert the output from a 0 to a 1, so the statement becomes true. So we also have assignment operators, and in the next chapter I would love us to start what we call decision making in C programming. This is where we look at if statement, else statement, etc. Thank you for your time. It's a new age.